Okay, so today we're looking at transition matrices still, using a rule. So when you see this rule Sn plus 1, all that is a way to say how you get the next one, okay? So how you get the next one, this is the rule, and when it says that, and that's using the one before. Does that make sense? So say you had to get state 6, you'd be using state 5 in there. Does that make sense? If you wanted to get maybe state 1, you're probably putting state 0 in there. So what we've got to be careful though with these ones, see how now we have this extra matrix that we're going to be doing something with. So it could be adding or it could be subtracting. When you see the extra bit in the formula, you are no longer can use that power trick. Remember the power trick we were talking about? You can't use the power trick when you see these formulas. So when you see these formulas, there's no other way but to do it step by step. So say they gave you state 1 and they want you to get to state 4, you're just going to have to do step by step by step, yes? Now because of that, you'll know it's probably one of these anyway, because they won't make you go too far ahead. Generally, it's about 2 steps and you're where you are. So let's have a look at this question here. It says determining the nth state from a rule. Okay, so a rental starts with 90 cars located at 50 located at Bendigo and 40 at Colac. So you can see that here, there's our SO, our beginning state. And cars are usually rented and returned in the same town. However, small percentages of cars rented in Bendigo return to Colac and vice versa. A transition diagram is set up. So you can see here, up here is Bendigo and Colac and Bendigo and Colac. And you can see there's the 80%. And remember, what do the columns have to add up to? 1, good. So there's your transition matrix. Now they're also saying to increase the number of cars, 2 extra cars are added to the fleet each location each week. And this can be seen. So can you see they're going to add, here's the rule, they're going to add this each week. So that's going to follow the same pattern, Bendigo and Colac. So how many cars are they adding to each place? 2, good. So 2 cars are getting, can you see that? 2 cars are going to get added to Bendigo and that. So what the rule says there is, so you can see how we get the next one. This is the rule. We're going to do the transition matrix times the one before, and then we'll add matrix B. Okay? Now, be careful. You've got to do it in order. So can you see over here, it says determine week 1, so I'd want week 1. So I'm actually going to do the transition times the one before plus B. Now can you see I've done that here? The transition times SO plus B, and then I've got the answer. So this is the answer for week 1. So then when they ask me to do week 2, I'm going to do the transition times the week before, which would be week 1 plus B. So can you see I've put that into there and we get the next one. Do you understand? So you can just press the up key, copy it, but just make sure you adjust this one here to be the new state, yeah? So you can copy it, but be careful. So this is actually, this one's week 1 and this is week 2, state 2. So I think down here they're just saying, unfortunately, a recurrence rule, so that's what I'm talking about, does not lead to a simple rule for the state matrix after n steps. So what that's telling you there is you can't use the power trick, okay? So you have to do it step by step. So let's go have a look at another couple ones. So here is another exam question. So this was going on about, I think we used this example in the other ones. So a series of extra rehearsals commenced in April. Each week the participants could choose extra dancing rehearsals or extra singing rehearsals. The matrix equation used to determine the number of students expected at each of these rehearsals is given by. So can you see that the rule here, can you see you've got this extra bit, so extra one. So that means you can't use the power trick. So we're going to have to do step by step. Here's your transition matrix, and we will call it a transition because it adds up to 1. All right, so they're saying that's how you get. So if this is the extra rehearsals, this is dancing and this is singing. What happens, because you're minusing, what do you think's happening? How many people are dropping off the extra rehearsals for dancing? 5, yeah? And how many are dropping off for the singing each week? 7. So that shows what's happening. So calculate the number of students here who are expected to attend the singing rehearsal in week 3. So can you see we've been given L1, yeah? And we want to get to, obviously, L3. All right, so you can see over here on my calculator, I did the transition times, now I've put L1 in there, and then minus that one, and I got this will be, so this is L2 here. Now because I want L3, I'll do the transition now times L2. So can you see I put that number in there? Yeah. And now I've got, this is L3. So calculated the number who are expected to attend singing rehearsals. So I found L3 to be 168. And that's dancing and that's singing. So if I'm answering the question, how many are doing extra singing? 68, yeah? Singing extra, whatever. Okay, of the students who attended rehearsals in week 3. So be careful when they say that. Of the students who attended rehearsals in week 3. So what that means is, you need to total the total of students in week 3. So that would be in L3. So you're going to, wouldn't you add those up? So 168, so it actually equals, we've got 168, yeah? How many of those are not expected to return for any rehearsals in week 4? Oh, we don't really. Well, here, if you have a look, this is week 4. I've done week 4 here. So you could do it a number of ways. So we did L3 and then we found out this is L4. So if you add them together, what's that? That's 156, yeah? And if you look, what's the difference? 168 minus 156 equals 12. And what's that magic number? Isn't that how many those are anyway? So it depends how you look at it. You could have worked it out that way, or you could have just known, if we're minusing that matrix, we know 12 are dropping off every week. All right? So that's another example of you have to go step by step. Can you see they only made me do 2 steps? So if you've got to go from, all of a sudden you're going from week 1 to week 20, it's probably you don't have that extra matrix. You're just doing the normal ones. All right, so let's do, now this question here was a really poorly done one in an exam. So it's crucial. It's not so much, it is a transition matrix, but it's more using the matrix multiplication. All right, so let's go through this. A large population of martin birds migrate each year to a remote island and nest and breed. There are 4 nesting sites, A, B, and C, D. Researchers suggest that the following transition matrix can be used to predict the number of martin birds nesting at the 4 sites in subsequent years. An equivalent transition diagram is also given. So you've got the transition and you've got the diagram. So they said 2,800 martin birds nest in Site C in 2008. All right, so we've got this. So really, what we're saying, we know in the year 2008, we'd have A, B, C, and D. They've just told me there's 2,008 at site C. So I'm going to say 2008. I know that. Okay, of these mutton birds, the number that nests in site A in 2009 is predicted to be. So of these 2000, did I write the wrong number? Sorry. 2,800 in there. Yeah. Of these 2,800, the number that nests in site A in 2009 is predicted to be. So let's have a think about how transitions work. So wouldn't we, if we were trying to find the state 2009, we would have done the transition times the state 2008. Do you think that? Yeah? All right. So what you think about it, I'm just going to cut this out. So I'm going to move it over here. So we would have had that transition, and we would have times it by the 2008, yeah, which would have been A, B, C, and D. So, and then it would have given me an answer. Okay. So when you think about it, oh yeah, and then yeah, we had 2,800. So if we look about it, we want to go the ones that were at site C, yeah, oh god, at site C, and they're going to go to where? Site A, yeah, which is this arrow. So you're going to say, what would that be? It's going to be 20% of the 2,800, yeah? And what would that be? So that ends up being that answer there. Okay, the transition, then we'll go to question 8. The transition matrix predicts that in the long term, the birds, the mutton birds will nest at site A only. So what you've got to look at, we don't really know how many birds there were to begin with, so we really don't know. So we probably have to interpret the transition. So have a look at the transition up here. Sorry, I've got to pause. So if we look up at this transition, can you see the 1 there with the B? Oh, no, you can't, sorry. So can you see the 1 in the transition there? So, or if you look over here, you got 100%. So once you get to site B, they just keep staying there. Can you see that? Because they go back. And then also, can you see the 1 at D? And that's the same. So after so many, it doesn't matter where the birds are, because eventually they're probably going to move off. So in the long run, we're probably going to see them nesting only at B and D, because those ones don't move once they're there. So the answer, oh my God, this thing's... All right, so we know that they're B and D. So this last question, oops, it says 6,000 mutton birds nest at site B in 2008. Assume an equal number of mutton birds nested in the 4 sites in 2007. The same transition matrix applies. The total number of mutton birds that nest in the island 2007 was. So what you need to do is we've got to think about probably like what's happened. So we know to get 2008, we would have to do the transition times 2007. So this we've got, and we also know they said that 2007, they each had an equal amount. So could you see that? Equal amount. So I might just call that, I'm going to call that X, 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 and X. Wouldn't that be the equal amount? Yeah? And we said that would give us 2008. And we don't know much about that, but we do know B, which was 6,000. Yeah? So I'll put the 6,000 in there. Okay. So what you do know is, so I'm going to grab that guy. Oh, not that one. So what you do know, you can use this to work it out. So if you think we're going to times it by this x, x, x and x, and it gives us the answer, but we know that we just know that B is 6,000. So why don't we use just that line, work out just that line with our multiplication to find it. So to get this spot, don't we go run and dive? Do you agree? Yeah? So we would have had, what we would have had is 0.35 times x plus 1 times x plus 0.15 times x, plus 0 times x, and it would have equaled 6,000, yeah? So you're going to use that. Oh, you dog. Alright, so I'm going to do that again. So you got 0.35 times x plus 1 times x plus 0.15 times x plus 0 times x equals 6,000. So you can solve for x, x. And you'll find out, I think x ends up being 4,000. And then, well, because this was 2007, you've got 1, 2, 3, 4 x's there. So 4 times 4,000 is, and it was that answer there, D. All right? Okay, so now the last little bit we've got to do, and I found that was sort of working backwards as well. So we're going to do this question, but this will show you how you can work backwards. All right, so question 7. A study of antelope population in a wildlife park has shown that the antelope regularly move between 3 locations, east, north and west. Let AN be the state matrix to show the population of antelope after n months after a study began. The expected population of the antelope in each location can be determined by using this rule. So you can see already it's got the extra matrix, which I'm talking about is here. So you've got to do anything that you do should be step by step. You can't do a power trick. And then they've given you all this. So down here we can see we've been given A3. So the number of antelopes in the west location 2 months after the study began, as found in the state matrix A2. So can you see we want to know, this is the question, A2 is the question, and we've been given A3. Okay, so think about how did we find A3? Using this rule, A3 would have been found by doing the transition times A2, is that correct? Minus D. Now if you look, what do we have? We have this one, we have this one, and we have this one. So we need to work backwards in finding it. So the first thing you would move, what would be the first thing you move if this was an equation? You're trying to get this one by itself. So what would you move first? Move this. So really you would have, I'm going to move it over the equal sign. What was a minus would become a plus. So you do that. And then it equals the transition times A2. So you would do this first. Now, if you move this T over the equal sign, it's timesing. What will it do on the other side? Divide, but we can't divide in matrices. What do we have to do? Times by the inverse, yeah? Is that what you said? Yeah, you know you did. Good. So, because it's at the front here, we'll put it at the front. So, we're going to times by the inverse, that, and then plus D. So you would have done that on your calc, or you can type it all in like that. And then it's going to tell us what A2 is. So I'm pretty sure I have put this in. Okay, so can you see I've done that here? So here is the transition to the negative power. So that's that bit. And then I've got, can you see I've got A3 plus the D. And then this was the answer. So this is east, north, west for A2. And what was the question? They want location west. So it is 2270E. Yeah? Yeah. So that's how you work backwards. So you have to work it out, but you've got to be careful. You've got to follow your, equation rules there too.